Hello and welcome to this short introduction to Explainable AI, which is my final project for the machine learning course. So in this project I tried to come up with a nice story how people are able to get a personal loan, and a bank, called the Banksy Bank, which is using a machine learning model to determine if this kind of persons get a loan. So I tried to come up with a nice story which you can read in the markdown cells all the time, of 4 persons: Alice, Bob, Charlie and Debbie, each of them with their own unique story. So please have a read. I try to make my best to make it somehow entertaining. For the whole project we used a personal loan data set, which consists of different features like the family size, level of education, age, experience, income and so on and so forth for each of these 4 persons, and the target variable, the personal loan, if a person gets a personal loan or not. First of all, we tried to section the whole notebook into different sections. So we start with the data preparation, so we do data cleaning in here. Then there's the sophisticated AI and buzzwordy machine learning model, which is top secret, the trade secret to the Banksy Bank. So we'll skip this section, you can have a read it yourself. And then last but not least, we check if the 4 people get a loan or not. So 1 means they get a loan, like Alice and Bob. 0 means the loan is not approved, for like there's the situation for Charlie and for Debbie. So Charlie is quite upset of not getting a loan. So therefore the Banksy Banks needs to explain why that's actually the case. So they use different methods to explain their black box or not so black box machine learning model. First, starting with the local interpretable model agnostics explanations, which is called LIME for short. So this shows the contribution of different features toward one specific explanation. So in this case for Charlie, like positive contributions toward the decision and negative contributions toward decision, and the magnitude of them. Next we also look into permutation importances. And since permutation is like scrambling up one feature after the other, you get like different drops in the outcome, so in the probability of getting a loan or not, which can be modeled as a distribution, and the distribution can be shown as a box plot. So we get this kind of box plots for each of the features. Next we can see the Shapley values. So we see like which features contribute the most towards the outcome on average, basically. So we can order the importance of the features somehow like this as well. Next we use the summary plots of Shapley values, which is a little bit more insightful, because sometimes you have like if one feature has a larger value depicted with red, then there's also a bigger impact on the model, positive impact on the model output, and this is can clearly be distinguished between the negative or like lower feature values depicted in blue. Sometimes these kind of values are more mixed up a little bit in here, so you get some more information in there. Next we use partial dependence plots to see like how we can what's the influence of small changes of different features. So if you're in a region with a large gradient, like small changes have a large impact on the output. If you're in regions with smaller gradients, small changes in the input have small changes in the output. We do this also in 2 dimensions, so we have these 2-dimensional partial dependence plots. Then we look at all these, or we analyze all these features basically one after each other, and we also look at the force plots, so Shapley values as force plots. So there's which represents features which are contributing towards a positive outcome, which are depicted in red. The features which contribute to the negative outcome are depicted in blue. And last but not least, Banksy Banks tries to debug their model, so analyze if there's some problem with it. They check for bias and variance, they check for different metrics like precision, recall, F1 score, and accuracies. They check for balanced dataset, which in this case clearly is not the case, using also the confusion matrix. Then they look for strongly correlated features, which they'll be able to find using a pair plot or like the heat map of the correlation. As you can see, experience highly correlated with age. And last but not least, There's the happy end. So Alice and Bob, they're super happy about their loan approval. Charlie knows what he has to do. He has to change some stuff. So basically get a larger, higher level of degree of education, or found a family first and get a house after, not the other all the way around. And Debbie, as you know from her backstory, probably by reading about this, so she's a musician and she didn't get a loan, but she got a call from Keith Richards from the Rolling Stones, so she's able to tour with the Rolling Stones and doesn't have any problem anymore because she, at least financially, so she doesn't need a loan to buy her dream house. So thank you so much, and hopefully you liked the introduction.